third part of this chapter deals with maximum and minimum problems. In example 5. So the child is playing with a yo-yo. The yo-yo leaves the child hand when t equals 2, travels vertically in a straight line but will return to the child hand. So it's going to go down and up again. The distance s of the yo-yo from the hand is given by 0.6t plus 0.4t squared minus 0.2t cubed, between t equals 0 and 3. So it leaves child's hand after when t equals 0 and returns child hand after 3 seconds. So the first part of the question asked us to justify the restriction between 0 and 3. Okay, well, so let's try to factorise this. First thing we're going to do is take out 0.2. So it's going to be 3t plus 2t squared minus t cubed. I can then take t out. And then that should factorise. In fact, what I'd be tempted to do, I don't particularly like these problems where you've got minus t squared. You can of course do it. I'd be tempted to actually take out minus 0.2t and then make it t squared minus 2t minus 3. So that's going to be a little bit easier to factorise. Was that t minus 3, t plus 1. Okay, so it's going to go through the axis at 3 and minus 1 and at 0. We need to see determining for a cubic graph whether it goes to heaven or hell. Well, or you can do this by looking at what happens when t is really big, or looking at a value that's say bigger than 3. So let's look at what happens when t equals 5. When t equals 5, s equals minus 1 times 2 times 6, which is minus 12. So we know the graph's going down. So it's going to look something like down. So it's going to go through 3, go through 0, and go through minus 1. And that's 2, and this is displacement. So this is what it leaves the child hand. It's a bit confusing because it's going up in the air, whereas the yo-yo is going to come down, obviously. But this is showing you how far away from the child's hand is. So at this point, it's the furthest away from the child's hand, and it comes back to the child's hand, and then it's going in the negative, so it'll be above the child's hand. So this is why the restriction needs to be between 0 and 3. So it returns the child hand at 3 seconds. So you can't get a solution when t is either bigger than 3 or when t is negative, but you can't have a negative time anyway. So it's already returned to the child's hand there, so this part of the graph is nonsense. What it says in part B, though, is to work out the maximum distance of the yo-yo from the child's hand to 3 significant figures. Well, it's tempting here to say it's at 1.5, but we don't know this is symmetrical because it's a cubic graph. So what we need to do is work out the value of this point here, which is called a stationary point. And it's at stationary point here when the velocity is 0. So at the bottom, when the yo-yo reaches the bottom, it stops and then comes back up again. So when it reaches the bottom here, the velocity is 0. Well, how do we find the velocity? We differentiate the displacement. So velocity is ds dt. So that's going to be 0.6 plus 0.8t minus 0.6t squared. And we want the max when v equals 0, or ds dt equals 0. So you get a stationary point when you differentiate and put it equals 0. You'll have done that before in core, I presume. So we got 0.6 plus 0.8t minus 0.6t squared equals 0. If I times everything by 10 and actually make the quadratic positive, so times everything, say, by minus 10. So we get minus 6 minus 8t plus 6t squared equals 0. Divide everything by 2, 3t squared minus 4t minus 3 equals 0. Factorising, I don't think that's going to factorise. So we could either complete the square, or we could use the quadratic formula, or just stick in the equation solving your calculator is the easiest way of doing it, but we'll use the quadratic formula. So it's minus b plus minus square root b squared minus 4ac all over 2a. So b is minus 4, so minus b is 4, plus minus square root. If you're doing this on the calculator, make sure you put this in brackets, otherwise you might get a calculator error here. Minus 4 squared is 16, minus 4 times 3 times minus 3, so it's going to be plus 4, 12, 36, all over 6. So it's going to be 4 plus minus root 52 all over 6. The square root of 52 is going to be 7 and a bit. So time can't be negative, so you're only going to have one solution where we are there. So fraction 1, 4 plus square root of 52 all divided by 6. There might be a slight break in the video there, there's a technical issue. But when we solve this quadratic equation using the quadratic formula, we end up with t being equal to 1.87. The second solution, where you do plus minus on the minus, there's no point doing that because you'll end up with a negative value of t, and time can't be negative. Finally, in this question, we have to work out the velocity of p at this time. So all we need to do is take that value using the ants function on the calculator and slam it into the original equation. So s is going to be equal to, so 0.6 ants plus 0.4 ants squared minus 0.2 ants cubed, 1.21 metres. Okay, again, that was the only example prior to exercise 11C, so if we smash on with that now.